Hello everyone. Today we'll be discussing the quick solutions of All India Akash Test Series Test 2A Paper 1, which was held on 24th November 2019. So let us start with the question number 41, which says that if the circle x square plus y square minus 2x minus 2y plus 1 equal to 0 is inscribed in a triangle whose two sides are given by xy equal to 0. If the third side has negative slope and cuts intercepts A and B on x and y axis respectively, then we have to answer the following options. So let us say this is the coordinate axis and this is the circle. Let us say the third side is like this. The circle has center as 1, 1, and let us say this point is A, 0 and this point is 0, B. Now seeing the figure, we can say that A is definitely greater than 2 and B is also greater than 2, which means that 1 by A is less than 1 by 2 and 1 by B is less than 1 by 2. So adding both, we get that 1 by A plus 1 by B is definitely less than 1. So from the given options, we can see that option number B is correct. Now also to check the other options, let us write down that delta is equal to R into S. Delta is area of the triangle, that is half into AB is equal to in radius of the circle, that is 1, into semi perimeter, that will be A plus B plus under root of A square plus B square divided by 2. 2 can be cancelled, so we are left with AB equal to A plus B plus under root of A square plus B square. Dividing by AB on both sides, we get 1 by A plus 1 by B plus under root of A square plus B square divided by A square B square is equal to 1. Now nothing of this sort is given in the options, so only correct answer is option number B. Next is question number 42, which says that two lines x plus y equal to 0 and x minus y equal to 0 are fixed sides of a triangle, and the third side is a variable line whose equation is lx plus my equal to 1, where l square plus m square is equal to 1. Then the circumcenter of the triangle lies on the curve. Let us say the triangle is like this, where the side this is x plus y equal to 0 and this side is x minus y equal to 0. Now these two lines have perpendicular slopes, so they are at 90 degrees. So this point of intersection is 0, 0 and this third side is lx plus my equal to 1. Now to find the point of intersection A, let us put x equal to minus y, so we get minus ly plus my equal to 1. So y is equal to minus 1 upon l minus m. So coordinate A is 1 upon l minus m, comma, minus 1 upon l minus m. Similarly, let's find coordinate B by putting x equal to y. So we get ly plus my equal to 1, that is y coordinate is equal to 1 divided by l plus m. So coordinate of B is 1 upon l plus m, comma, 1 upon l plus m. So this is the coordinate B. Now we are talking about circumcenter of this triangle, which will be midpoint of AB. So x coordinate will be equal to 1 divided by l minus m plus 1 divided by l plus m divided by 2. Let's take 2 on the other side. So 2x is equal to l square minus m square, and in the numerator we will have 2l. So x is equal to l divided by l square minus m square. Similarly, let's find now y coordinate, and that will be 2y equal to 1 divided by l plus m minus 1 divided by l minus m. So that is equal to l square minus m square, l minus m minus l minus m. So that is equal to minus m divided by l square minus m square equal to y. So let us find x square plus y square from here. So that will be equal to l square plus m square, that is equal to 1, divided by L square minus M square whole square. right? Also, let us find here x square minus y square. That will be equal to 1 divided by L square minus M square. So, locus will be x square plus y square equal to 1 divided by L square minus M square whole square, that is equal to x square minus y square whole square. So, this is the locus of the circumcenter. So, from the given options we can see that the correct answer is option number C. Next is question number 43, which says that let ABCD be a quadrilateral in which AB is parallel to CD, AB is perpendicular to AD, and AB is equal to 3 times CD. If the area of quadrilateral ABCD is 4 square units, then the radius of the circle touching all the 4 sides of the quadrilateral is, let us say this is the circle and the sides are like this. Let us say the coordinates are like this: A, B, C and D. AB is perpendicular to AD and AB is parallel to CD, right? Let us take this point as origin, that is 0, 0. So this point will be, let us say 3A, 0. So line CD will be y equal to 2r, where r is the radius of the circle. So this point is 0, 2r, and this point will be A, 2r, because AB is equal to 3 times CD. I hope this is clear. Now it is given that area of the quadrilateral ABCD is 4. Here trapezium. So its area will be half into sum of parallel sides, that is A plus 3A, into distance between them, that is 2r. So this is equal to 4, which means that value of AR is equal to 1. Now we have to find the radius of the circle which is touching all the 4 sides of the quadrilateral. So let us firstly write the equation of BC. Now that will be y minus 0 equal to 2r divided by A minus 3A, that is minus 2A, into x minus 3A. So this is equal to 2 upon 2 get cancelled. So A can be written as 1 by r. So this is minus r square multiplied with x minus 3 upon r. That is y plus r square x minus 3r is equal to 0 is the equation of line BC. Now as BC is tangent on this circle, so we can say that this distance will be equal to r, that is r plus r cube minus 3r divided by under root of r raised to the power 4 plus 1 is definitely equal to r. That is r cube minus 2r is equal to r times under root of r raised to the power 4 plus 1, and here we have its mod. So we can say r square minus 2 whole square is equal to r raised to the power 4 plus 1, that is 4 minus 4r square is equal to 1, that is 4r square is equal to 3. So we can say radius of this circle is equal to root 3 by 2. So correct answer is option number B. Next is question number 44, which says that let C1 and C2 are two circles. The tangent at 1, 2 to C1 meets the circle C2 at A and B. The tangents drawn at A and B to C2 meet in T. So we have to find the coordinates of T. So we have two circles over here. This is C1 and this is C2. Now tangent at 1, 2 meets the circle C2 at A and B. The tangents drawn at A and B to C2 meet in T. So let us assume the coordinates of T are h, k. So from there we can say equation of chord of contact AB will be T equal to 0. That is hx plus ky is equal to 9 is the equation of AB. Also its equation can be written as equation of tangent at 1, 2 on circle C1. So that will be x into 1 plus 2 into y equal to 5. So these two are representing same line, which means that h upon 1 is equal to k upon 2 is equal to 9 by 5. So coordinates of point T is 9 by 5, 18 by 5. So from the given options, option number D is the correct choice. Next is question number 45, which says that a circle of radius r touches the parabola y square equal to 4ax at the vertex and the center lies on the axis of the parabola. Further, the circle completely lies within the parabola. Then the largest possible value of r is, let us say this is a parabola. So we have a circle here which is lying completely inside this parabola and this center lies on the x-axis. So let us take the coordinate of center as r, 0 and radius is also r. So equation of such circle is x minus r whole square plus y minus 0 whole square is equal to r square, right? Now if we take any point on the parabola as at square, 2at, then we can say that distance of point P from Q is definitely greater than the radius of the circle, that is r. So let us do that. PQ will be at square minus r whole square plus 2at minus 0 whole square should be greater than r square. So we get from here a square t raised to the power 4 plus r square minus 2ar t square plus 4a square t square minus r square should be greater than 0. These two will get cancelled. T square will also get cancelled. So we left with a square t square minus 2ar plus 4a square is greater than 0, which means that its discriminant should be less than 0, that is b square minus 4 into a into c, that is 4a square minus 2ar is less than 0, which means that 4a square minus 2ar is greater than 0, that is 2ar is less than 4a square, that is r is less than 2a. As the circle is lying completely inside it, so it can touch the point Q also, which means that here we should put PQ greater than equal to r. That will give us r less than equal to 2a. So largest possible value of r is 2a. So option number A is correct. Next is question number 46, which says that the smallest possible positive slope of a line whose y-intercept is 5 and which has a common point with the ellipse 9x square plus 16y square equal to 144 is. Now equation of tangent on ellipse is y equal to mx plus minus under root of a square m square plus b square. Now our ellipse is x square divided by 16 plus y square upon 9 equal to 1. So it will be a square m square plus 9. Now it has been given that tangent has y-intercept 5, that is it is passing through the point 0, 5. So 5 square is equal to 16m square plus 9, which means that m square is equal to 1. Now it is talking about smallest positive slope. So positive slope is m equal to 1. So correct answer is option number B.